In this series, you will learn everything needed to create bow and arrow mechanics just like these. Alright, to create all of this from scratch, I will teach you a lot of things, both beginner and intermediate level, including blending animations and creating aim offsets, creating dynamic crosshair widgets, shooting arrows with physics collision, calculating the arrow's path trajectory, visual and sound effects for different actions, and so much more. The full project files will be available to download on my Patreon, including all of the assets that I will be using, such as the bow mesh, the animations, visual and sound effects, and so on. And of course, all of the tutorials that I've ever made will be available as well to download. In this part, we are going to be setting up our player. We're going to be equipping the bow, we're going to have specific bow animations and a locomotion blend space, and we're going to be setting up an aim camera that also modifies the character's movement controls. And we are going to do all of this in a very modular way. I'm going to show you how to set up the blend space from scratch, as well as how to create an actor component which will house all of our bow mechanics. So let's get started. All right, so I'm starting off with the third-person template here. And usually when creating any new project, I like to begin with the 3 C's, which is character, controls, and camera. So let's first start by creating our player character. Now, since this is the third-person template, we have the default third-person character, but I will be copying that and creating our own player from it. So opening up our third-person blueprints and here our third-person character, I'm just going to copy it and paste it and call it BP player. And I already have a player folder here that I created just to, I have animations that I will show you in a bit. But yeah, create a player folder and let's move this player character that we just created into it. And also right now the default third-person character is the default pawn. So we have to change that to be our player character. And we do that in the third-person game mode. So you open up this third-person game mode. And just under default pawn class here, select the BP player we just created. All right, so now if you play, nothing should be different, but now we are controlling our BP player blueprints. Now to make our player character a bit unique, I'm just going to change the color of the mesh. So over here where we have the default materials, I already created 2 instances of these materials to make them red. You can do that just by changing the tint. So if you go over to the material, click on tints, and then you can just really change it to any color you want. And let me just undo this. So I've already created 2 red ones, so I'm going to use them here. So use the red. So now we have a more unique looking player character. All right, now that we finished the first C, which is character, now let's look at controls. For controls, mostly everything will be in the character movement component, and we're going to be adjusting some of these things as we move along, but I want to explain a few of the most important things that are overridden by the default mannequin. So if you go here and search for rotation, these 2 are very important. Use controller desired rotation and orient rotation to movement. So orient rotation to movement basically means that wherever the camera is pointing, so right now I'm just pressing W on the keyboard and moving the mouse. So the character moves to where the camera is moving, and that's orient rotation to movement. If I turn this off, look what happens. Now I'm pressing W, and the character is strafing, and we don't have strafe animation, so that looks very weird. So we're going to keep this as orient rotation to movement when we're not holding a bow, when we're not aiming. But when we aim, we're going to change this, and I'll show you in a bit. And use control desired rotation does exactly that. So if I am moving my camera here, the player still follows the rotation. But if I'm now moving left and right, the player is still facing forward because the camera is facing forward. Whereas if I disable this and I move left and right, then the player moves to the left and right. All right, we're going to touch on controls later on, but for now I want to talk about animations. So the default mesh now is using the ABP Quinn, which is a child of ABP Mani, but I want to create our own animation blueprint. But I will start off with this one. So we have this animation blueprint for Mani. I'm just going to copy and paste it. I'm going to call this ABP player. And I'm going to move it to the animations folder of the player. Yeah, so we have player here and animations. And we're going to select it in the anim class. So search for ABP player and select it. So the animations that I'll be using for now, I'm going to, of course, be adding more animations and showing you how they look like. But the animations now are these movement or locomotion animations for moving forward, back, left, and right with a bow. And these animations I all got from Mixamo. And of course, Mixamo animations are free to use, but I just retargeted them to the Unreal Mannequin to be able to use them on the UE5 skeleton. All right, now let's open up our animation blueprint and let's see what we're working with. So for the animation blueprint, the default, again, ABP Mani, which we copied, sets some variables for us to use. Ground speed, a should move or shouldn't move based on how much the ground speed is, and whether they're falling, means jumping or in the air. And we're going to use these variables, and we're going to add a few more. But also let's look at the anim graph. So the anim graph has a locomotion state, which has idle and walking or running, which is this blend space. But we will be creating our own blend space from the animations that I showed you. And we'll also be getting rid of the this idle state because we're going to add the idle animations in our blend space. So let me show you how we are going to create this blend space. All right, so in our animations folder here, I'm going to right click and search for blend space. Now you're going to have blend space 1D and just blend space. The blend space 2D means you have two variables that control the blend. And I'm going to select the SK mannequin and call it blend space bow locomotion. Now we're doing a 2D blend space because we want to blend animations based on two variables. And those two variables are the speed at which the player is moving. So if they're idle, their speed is 0, then we do the idle animation. And if they are full speed, then we do the walk or run animation. And that's one variable. The other variable is direction. So since we're going to be doing a strafing animation, so there is moving left, moving right, as well as forward and back. And that's going to depend on the direction the player is facing. And these two variables are going to be our axes here on the blend space. So we have a horizontal and vertical axis. So the horizontal axis is going to be our direction. And the direction has a value from -180 to 180 because then it's a 360-degree turn. And we're going to keep the grid division at 4. And for the vertical axis, we're going to call it speed, and that's just going to have a minimum value of 0, which is idle, and maximum value of 500, which is running at full speed. And then this gives us, you see the names of the axis here, and it divides the grid for us. So I'm going to search for my bow animations here and show you how we're going to add them. So first of all, on the horizontal axis where the speed is 0, regardless of direction, we're always going to use the idle animation because you're just standing still and it doesn't matter where you're looking. So I'm gonna just move all of these on the 4 grid points. So here I'm using the idle animation with the bow held in hand. All right, and now when the direction is 0 or like facing straight forward and the speed is full, then we want to use the run forward animation. So I'm going to pull this and hold it here. By the way, if you hold shift while you're moving an animation, it snaps to points on the grid. If you're not holding shifts, then it's wherever your mouse is. So I'm holding shift because I want it to snap to this point here. So now you see that if I hold Control and I move around the graph, it's going to show me the blend between the animations. So here at 0, I'm idle. At full speed, I'm walking forward. And somewhere in the middle, I'm walking slowly. Now we're going to do this for left and right as well. So left is right here, where direction is -90. And right is right here, where direction is 90. And then direction 180 and -180, that's the moving backwards. So here for direction 180 and -180, backwards. So now we have a blend space that blends between these animations based on the direction and speed of our character. Now, you can have multiple, right now I have only full speed and idle, but you can also have run, walk, jog, sprint, as many animations you want along these grids to make it, if you have variable speeds. But for me, I only have one speed. You're either standing still or you're running at full speed. This is, of course, more relevant when you have a controller and the speed is variable based on how much you press the analog stick on the controller. All right, so how do we use this blend space that we just created? Well, back here in our ABP player, I told you we're going to get rid of the idle state, so we don't need that. But we're going to keep our walk-run states. And we're just going to, And we're just going to replace this blend space with the new one that we created here. So we're going to search for our blend space bow locomotion, and we are just going to add it here. Now we need the two variables that we mentioned on the graph, the speed and the direction. Now speed we have, but direction we need to calculate. And that we're going to do also here in the event graph. All right, so to calculate direction, we're going to use a function called calculate direction. Now this function takes a velocity and rotation and then gives you a direction. Now the velocity we've already have here as a variable calculated, so we're just going to use it here, velocity. And the base rotation we're going to get from our character. So again, character we have as a variable here, which is just our owning actor cast to character. So we are going to get this character variable and get the actor rotation from that. All right, and that gives us direction. So we're going to right click, promote this to variable and call it direction. And we are going to do all of this. We're going to add a new pin here on this sequence and do it here. And maybe we can also comment this and say direction. All right, so now if I go back to my walk run state, I have a direction variable that I can plug in. Perfect. So let's play and see what this looks like. So now I'm idle, I'm doing the idle animation, and I'm moving, I am doing the move forward animation. But of course, as I mentioned in our character movement, I have orient rotation to movement, which means I'm only ever going to be moving forward. Even if I'm looking right, the character moves right, so I'm always doing the forward animation, I'm not strafing. Now, if I go back now, because we allow strafing, since we have this direction variable in our blend space, I can say, go back to my rotation here, and say use controller desired rotation instead of orient rotation to movement. So I'll check this and not this one. And now you can see that we have strafe animations, and now the left and right are working well. And depending on your animation, you're going to want to modify the speed on your blend space. So right now I have this set to 500. I think it works well for this animation, 500. Maybe I would want to decrease it a bit, but yeah, I'm not going to be too picky with how well it looks. I think this is looks pretty fine. For now, I'm going to revert this. So I want orient rotation to movement to be the default and only switch it when we are aiming the bow. And we will get to that in a bit. But for now, the next step is actually equipping and showing you the bow mesh that we'll be using. So I already have a folder here called bow, and it has a skeletal mesh for the bow. All right, so the bow I have here, I modeled myself in Blender, and you'll see that it's a skeletal mesh. That means it has bones, and that's because it's also animated. So I also have an animation for drawing the bow that I also made in Blender. And we're going to be using these animations as we aim and draw the bow. Of course, if you want this specific bow with these animations, you can get it on my Patreon, but you can also follow along with any bow or animations that you already have, or you can also create your own. But first, let's see how we're going to attach the bow to our mesh. Now to do that, we can go to our player and see what mesh we're using. Here we're using SKM Quinn Simple, so I'm just going to double click that. And we want to get a reference pose, so I'm going to say use a specific animation, sorry, not reference pose. And let's say we're going to do the bow aim animation, and we're going to also talk about this animation in a bit. But I'm gonna just use this as a reference to where the bow should be placed. Now, I of course want the bow to be placed in the left hand here based on this animation. So I'm going to look for my hand underscore L. I'm gonna right click and I'm gonna create a new socket. Where is create socket? Oh, add socket. And I'm just gonna rename this socket to bow underscore socket. And I'm going to right click on this new socket and add a preview asset, which will be my bow mesh here, just so I can preview it in this window. This is just a preview. It doesn't actually change the character in game. There is no bow yet. We have to still spawn this. But we can now move this socket to the right place, rotate it until we're happy with the positioning. Now, I already did this before, so I know what these numbers will be. So I'm just going to plug them in. All right, so I just plugged in the numbers and this looks pretty good. So of course you can keep playing around with this until you find the right transform for your socket. But as I mentioned, this doesn't spawn the bow yet and attach to the player, so we still need to do that in our BP player. But to be able to spawn something, we need an actor for it. So let's create this actor. So in our bow folder, I'm going to right click, create a new blueprint class of type actor and call it BP bow. Open it up and we're going to add one component, which is a skeletal mesh. Call it the bow mesh. And over here on the right for the skeletal mesh asset, I'm going to search for my SKM bow. We're going to be adding an animation blueprint for the bow as well to animate it, but I'm not going to do that right now. For now, let's spawn the bow and see what it looks like in our hand. So back here in our player, I'm going to show you the attachment in the player, but this won't be the place where we're going to do it moving forward. And I'm going to explain why in just a second and what's the proper way of doing it. But let's see how we spawn and attach. So let's say here on begin play, I can spawn actor from class. And I can search for the BP bow that I just created. Spawn transform doesn't matter because we're going to attach it to the player, but this has to have a variable. So I'm just going to say make transform. So just give it a random variable or just a 0. You can also just right click and split. This also gives it all zeros, so you can also do that. And then this bow, we're going to attach it to component. So attach actor to component. And the component here is our mesh. So it's this mesh. And now we just need a socket name, which is the socket we just created on our left hand called bow underscore socket. And the rules here are very important. This is what to do when you attach the bow to the mesh. And what we want to do is snap to target. That means take the value of the socket. So take the location, rotation, and scale of the socket and use that for the bow. So if we play now, the character is holding a bow in hand. Very nice. And the bow animations look perfect. But as I mentioned, this won't be the place where we do it. I want all of the bow mechanics to be in a separate actor component. For example, this character movement is an actor component and can be applied to any character. I want to create our own custom bow mechanics actor component so that this system that we build is very modular and you can take this actor component and place it in any project you want, on any character you want, and also to separate the logic of our player from the logic of our bow. You don't want these to be too intertwined or dependent on each other. So let's see how we're going to do that. I'm going to open up my bow folder again. I'm going to right click here and create a blueprint. And I'm going to create a blueprint of type actor component. If you don't see it here, just open all classes and search for actor component. And I'm going to call this AC for actor component underscore bow mechanics. All right, so now when we have our actor component, we just need to add it to our player. And you do it here in the components tab. So add our AC bow mechanics. Great. So now we have character movement, which is an actor component, as well as our bow mechanics that we just created. And we're going to move this functionality of equipping the bow to our actor component. So I'm going to cut this out, open up our AC bow mechanics, and I'm going to create a new function just to keep things a bit tidy and call this equip bow. And I'm going to paste these two things that we copied. Now, you'll notice that there are a few things that the player knows that this actor component doesn't, which is this mesh. There is no variable for mesh here. The bow socket, maybe we want this to be a variable, and the class of the bow that we're spawning, maybe we also want this to be a variable so that we can equip any bow into any socket on any character. So how do we make these variables and where do we actually plug the values in? Now I can make these variables on the function itself, this equip bow function, but I don't want them to be part of just the function. I want them to be part of the entire actor component. So I'm not going to do that. I'm going to undo that. I'm just going to create them as variables here. So I'm going to create one variable, call it our bow class. And this is going to be of type BP bow, but make sure it's class reference. So that means that we can have multiple children of the bow class. So you can have maybe wooden bow, metal bow, whatever. And then the class name that you pass here is the one that will be spawned. So then I can just take this variable and plug it here. And the socket as well, we want this to be a variable. So I'm going to create another variable here, call it the bow socket name. And this is going to be of type name. So we can just plug this in here as well. Now, what's left is the mesh. Now, the mesh, I'm not going to make a variable because we can already get the mesh from within the actor component without having to pass anything. And let me show you what I mean. So back in our event graph on begin play, I'm going to delete the tick for now. On begin play, I'm going to get something called an owner. So right click and search for get owner. Now you'll see this, it's under the components tab because any component has an owner, and this means that this is the actor that the actor component is applied to. So for our case here, the owner will be the BP player. So I'm just going to get the owner and I'm going to cast it to, I could cast to our BP player, but this means that this actor component will now only work with classes of type BP player. So I'm not going to cast it to player, instead I'm going to cast it to character. This means that this can work with any character. And the reason I'm casting at all in the first place is because the character has a mesh on it. So all classes of type character have a mesh that I can get, just like this. And I'm going to need this mesh to spawn the, to attach the bow to it. So I'm just going to cast to character on begin play and promote this to a variable and call it our character ref. So just a reference to our character. Of course, before the cast, it was an actor, and an actor doesn't have a mesh. I can't get a mesh on any actor. So back in our equip bow here, our parent will be our character ref that we just created. Oh, sorry, our character ref get mesh that we just created. Yep. All right, so now if I go back to my event graph, I can call equip bow here on begin play. Equip bow. But this is going to give me an error. It's not going to work. So if I play, there is no bow, and I have an error. And the reason why I'm having an error is because we actually didn't set the values for bow class and for bow socket name. And we're not going to set them here because, of course, now I am in the actor component itself. We want the person using the actor component or the class using the actor component to set these variables. So back in our player here, just like we set certain values on our character movement, we're going to click on our AC bow mechanics and set our values here as well. So for bow class, we're going to click the only class that we have, And socket name, we're going to select bow underscore socket, because we know for this player, for this mesh, that's the name of the socket that we created. Now if I play, we have a bow. Perfect. And this, now everything that we do related to the bow will be inside this AC bow mechanics, and we'll be communicating between the player and the bow mechanics through variables and potentially events as well. All right, so our character now is looking pretty good. We talked about animations, we touched on controls a bit, but we still haven't discussed camera at all or the bow controls. So let's start discussing the aim state. So I want that when I hold right click, I aim the bow, and when I let go of right click, I am not aiming the bow anymore. So let's see how we can do that. So again, anything related to the bow will be in our actor component, our AC bow mechanics. So to know if we're aiming or not, I'm just going to create a single variable here called isAiming, and that's going to be of type Boolean. And I'm going to create two custom events, one called aimBegin and one called aimEnd. For now, these two events will just set the isAiming variable. So the aimBegin sets it to true, and the aimEnd sets it to false. And now we want to set up the input action that will trigger the aim state. And as I mentioned, I want it to be on right click and when you hold right click. So let's see how we're going to do that. I'm going to be using the new input actions from UE 5.1. So that is somewhere in third person input and actions. So we already have jump, look, and move. These come by default in the third person blueprint. So I'm going to create a new input action here, and I'm going to call it IA underscore aim bow, for example. And let's open it up. All right, so the only thing we want to modify here is the trigger. So I'm going to add a new trigger, and I'm going to use hold and release. And this is because I mentioned we want two events, when we start pressing and when we release the right click button. So the hold time threshold, this is how long do you have to hold it for before it's triggered. I'm going to set this to a very low number, 0.1, because I want it almost as soon as you hold, then it becomes triggered. And the actuation threshold, this just depends, like if you're using a controller, how much do you have to press the key before it actually gets triggered. 0.5 means halfway through, if it's like a trigger button, for example. I'm going to leave that as is. So now we want to use this input action, or before we use it, actually, we want to assign it to the right click button. So we do this in this input mapping context. So open up IMC default, and you'll see that it has some mappings here. The jump is spacebar, the move is WASD, and so on. So there's a new, we're going to add a new one. So let me just collapse these. We're going to add a new one for our aim bow. And we're just going to have this be our right mouse button. So now when I press right mouse button, it triggers the aim bow input action that we just created. And we want to now use it in our player. So go over here in our player somewhere and search for IA bow aim. And click on this one, the one under, well, this first function. And when you expand it, you'll see that it has a lot of execution pins. Triggered is actually when it's released, as well as completed. So since it's a hold and release modifier that we added, then it gets triggered and completed at the same time. So what we want is on start, so as soon as we start pressing, we want to enable the aim state, and when it's completed, we want to end the aim state. So we're going to get our AC mechanics here and call aimBegin on start. And we are going to also call aimEnd on completed. And that's pretty much it. But of course, now if we play, nothing happens because we're just setting a Boolean variable, but we're not really using it or doing anything with it. So that's the next step. So what do we actually want to happen when we aim? Well, we want three things to happen. First of all, I mentioned we want as you aim, you want the character to move where the camera is pointing. So that means we want to use controller desired rotation instead of orient rotation to movement. We also want to change the camera to zoom in a bit to have like an aim state. And of course, we want the character to be in an aim animation pose. So let's start with the aim camera first. All right, so to preview our aim camera, I'm going to actually get our player here. So get our player and pop them in the world. And the reason is because I want this preview camera. So if I now click on my player, you'll see that we have the camera that we would see in-game. You can also pin it so that it doesn't move when you click on other things. But yeah, it doesn't really matter. I'm always going to be clicked on the player for now. So the two things for now that we want to modify for the camera when we aim is the field of view. By default, it's 90. When we aim, we can make it something like 60. So you see that it zooms in as I decrease this value. And the other thing is that the player is now in the center of the screen where you're actually aiming, and you don't want that. So I want to move the player a bit to the left. And to do that, I'm going to modify the camera booms, and the camera boom is just this red line that connects the player and the camera. So I'm going to move the camera boom's socket offset. So let's say I'm going to move it 100 on the X, 75 on the Y, and let's say 45 on the Z. So then our player is a bit to the right and we're zoomed in. And you can always use references from actual games on how they do this mechanics. So personally for me, I used Horizon Zero Dawn when I saw that they have this positioning of the player in the same way. And also Tomb Raider had the same sort of camera when you are holding a bow and aiming. They do modify some more things, and we're going to modify these things as well. But for now, this is going to be enough. So we just identified the values that we want to change, but now we need to actually add them when we aim. I can remove my player now again. So in our, when we start to aim, in our player character, I'm not going to do this in AC bow mechanics because this is related to camera, which is related to player. I'm going to create two custom events. One called aim camera begin, and another called aim camera end. So on the begin, I'm going to show you what values we're going to set, but then we're going to do it in a more smooth way. So if I just set the value, so if I get my follow camera here and say set field of view to 60, let's actually promote this to a variable and call it the aim FOV. And that defaults to 60. And then when the aim camera ends, we can set it back to 90, or we call it the initial FOV. Now it's good to set the initial FOV not by default here. We want to get that initial FOV from our initial camera movement settings. So on begin play, we get our character movement, sorry, not our character movement, get our camera. Get our field of view, and then this is going to be our initial FOV. That way, if you change it later on in the camera, so if I go to the camera and I change it here, then it's the variable itself changes as well. All right, so now when we start, if I just call aim camera begin and aim camera end, and I play, when I press right click, you see that it snaps to the new FOV right away. And when I remove, it stops. But there is no smoothing. We want it to be smooth. And we want the same for the camera boom as well. So let's see how the camera boom values will look. We're going to get this and say set socket offset. And again, this will be our, what we said, 100, 75, 45, and promote it to a variable as well. Call it the aim boom offset. And when we stop, we are also going to set this to a variable. promote variable, and we're going to call it the initial boom offset. But again, like I mentioned, the initial values should always come from the camera or the boom components themselves. So we're going to get the socket offset, and that will be our initial boom offset as well. All right, so now let's again look at it. The character is moving to the right place, and we are zooming in, but how do we do this smoothing? For that, we are going to use a timeline. And let me show you how timelines work. So let me move this down here a bit, and also these two, let's move them here. So I'm going to right click and say add timeline, and we're going to call this the aim camera timeline. Now, a timeline basically allows you to update certain values over time. And what we're going to do is we're going to double click this to open it up, and we're going to create a track. So we're going to add a float track because the value we want to update is a float, and I'll show you why. We're going to call this the aim alpha. And alpha just means the value between 0 and 1. 0 means we're not aiming, 1 means we're fully aiming, and anything in between, it means we're smoothing towards full aim. Now, the length is how long this will take. Usually we want this to be pretty quick, so let's say 0.25 seconds. And now I'm going to right click here and add a key. At time 0, the value is 0, and right click, add another key. At time 0.25, which is the end, the value is 1. So if I click these to fit the graph, you'll see that it just goes from 0 to 1 in 0.25 seconds. And this is just a linear line. You can also, what you can do is select both these points, right click and say auto. This will make it more of a smooth curve. So it slows in the beginning, then speeds up, and then slows again towards the end. That might seem a bit more natural, so I'm going to do that. Now, we just set up our timeline, but how do we actually use it? So when aim camera begins, I will say play. And when aim camera ends, I will say reverse. Now, I don't actually need to set these values again because they will already be reversed from the values that we set here. So I only need to call it once. And on update, this is going to happen periodically over time, and the aim alpha is going to keep going from 0 to 1. So on update, we want to do these things, setting our field of view and setting our camera boom, but we don't want to jump right away to our aim FOV and our aim boom offset. We want to smooth again towards that value. And to do that, we use a node called lerp, or linear interpolate. So look for lerp float. This takes in two values, your initial value, so our initial FOV. Oh, let me move this a bit. And our aim FOV. So it takes these two values, the start and the finish, and the alpha, which is our value between 0 and 1. So at 0, it will be initial, at 1, it will be aim FOV, and then anything in between, it will be between. And that's going to be our field of view. And we're going to do the same for the boom offset, but this time we're going to lerp a vector. So we're going to do linear interpolate for a vector. And the B value is our aim offset. And the A value is our initial boom offset. And the alpha is the same one. Let me also do this here to be a bit cleaner. All right. So let's see how this works. When I play, right click. Yeah, see, now it's smooth. And when I stop right clicking, it just goes back. And I didn't have to implement a specific, I didn't have to say reverse these values. I just put the pin towards reverse. I think it's going to actually be a bit faster. Depends on what you want. For me, this is fine for now. Now, the next thing we need to do is actually, as I mentioned, right now, I'm aiming, but when I move the camera, the character is still facing wherever they're facing. When you're aiming, you want the mouse or the aim joystick to control where your character is facing. Otherwise, you are going to aim here, you're going to shoot here, and the character is going to shoot somewhere else. So how are we going to do that? So for this one, I was debating whether to put it in the BP player or whether to put it in the AC bow mechanics, but I feel like the bow mechanics will be better because, again, the bow mechanics apply to any character, and a character always has character movement. So anything related to the bow specific character movement, I'm going to keep in the bow mechanics. And this sort of aim movement state is character movement related. So on aim begin and on aim end, we are going to modify these values. What we're going to do is we have our character ref here. We're going to get it, and then we're going to get our character movement component. Now, because every character has to have one, then by default, we will have this variable. And as I mentioned, to have the camera, to have the mesh follow the camera, then we need to use, we need to disable first orient rotation to movement. So this will be false. And then we need to call use controller desired rotation. Oh, not get, sorry, we need to set controller desired rotation. And we're gonna set that to true. And when we stop aiming, we're just gonna revert these two. So this will be true and this will be false. All right, let's see what this looks like now. If I play, right now I'm not aiming, so I can look around my character, but as soon as I press right click, perfect. Now the character is always looking to the direction that I'm aiming. One thing you might also want to modify is the rotation rate. So right now, if I move the camera really quick, you see it takes time for the character to rotate. And if you are trying to do like a fast-paced aiming game where the camera is pointing, you really want the character to always be pointing as well, then you might want to increase this rotation rate. To do that, it's also on character movement. So I'm going to pull off here and say set rotation rate. And I just need to increase the Z value here to something like 1,000. And then when we're done, we set rotation rate back to the initial value. Again, it's good to promote these two variables. So I'm going to promote this to a variable and call it the aim rotation rate. And I'm going to promote this to a variable and call it the initial rotation rate. And as I mentioned, for any initial values, it's always good to get them from their single source of truth. So again, on begin play, on begin play, I'm going to get the character movement. I'm going to get the rotation rate, and I'm going to use that to set the initial rotation rate. All right. So now when I'm aiming, the rotation is a lot snappier. The larger this value, the more instant it will be. And when I'm not aiming, then this value is, well, it's not going to really do anything because we don't really rotate with the camera. And that's it for part 1, where we set up our 3 C's, our character, controls, and camera. And the next part, we're going to be looking at the bow mechanics then. We're going to be adding an aim state with both aim animations for our player and our bow. And we're going to start looking at the mechanics for spawning the bow and shooting the arrows and so on. So I hope you enjoyed it, and if you did, please consider giving a like and subscribe. As I mentioned at the beginning, all of the project files will be available to download through my Patreon, so if you want to follow along with my specific bow and arrow and animations, you can get that on my Patreon, and of course you'd be supporting me and helping the channel. So thank you, and I'll see you in the next one.